Hi everyone. So it's Wednesday. I hope everyone is well. I did extend because of the wellness day, I did extend the homework and quiz an extra day. So you have another day to complete them. So before they were due on the 17th and the 18th, but I just felt like because I wasn't able to have office hours yesterday, I felt it would be fair to give everyone an extra day on the quiz and the homework. I thought that'd be fair. The next test, I know it's supposed to be, if I remember correctly, I think it said it was going to be on Monday, but it's going to be later sometime next week. It's probably not going to be on Monday though. I'll let everyone know. So let's see that. What was I going to say? I think that's it. Are there any questions at all?
Yes. How you doing, Professor? Good morning. I wanted to know, you said that you sent out an email saying the quizzes and the homework was going to be extended one day, so that's for the 19th, correct?
Mm-hmm. They're up there already, actually, the new dates.
All right. Thank you, sir.
Okay. You're welcome. You're welcome. Any other questions? I mean, the test will be on, I'm trying to think, it'll be on everything up to including this week, what we're doing. So the stuff we do next week will not be on the first test. And again, it will be take home, so you'll have a few days to complete it. Okay. All right. Okay, so I did email everyone the notes, and I also plan to do a worksheet today as well. So let me get started with the lecture. All right. Okay. All right. Okay, so remember last time what we've been doing is the AC method, as it's called. And again, this is just a reminder that it's there to help you with factoring. Okay, it's there to help you with factoring, basically. All right. So again, the whole idea is you have this trinomial ax squared plus bx plus c, where your leading coefficient, your capital A, is not equal to 1. If it were 1, you actually could use this procedure, but it's going to be a lot more work than necessary. And the whole idea is you're finding after you factor out the GCF, it's really good to do that first, only because it can make the process a little bit easier, mostly because the numbers can be a little bit smaller. Also, we saw this last time. If you don't factor out the GCF, excuse me, it's possible that what you have is not in this form. You know, it might be degree 3, but after you factor out the GCF, it will be in this form. Either way, after you do that, you want to find two integers whose product equals this product, A times C, and whose sum is equal to capital B. B, remember, is the coefficient of X. Then you're going to replace B by that sum. And what will happen is you'll have a polynomial with 4 terms in it. And then you get to apply factor by grouping. Oops. Okay. Again, that was, on the notes last time. So what I want to do is do another example. Then I was going to have everyone work on the worksheet. And then, of course, I'll go over it. Pretty sure I emailed everyone the worksheet. I mean, I will post it anyway. So, all right. So here's our first example. Now, even though this is a trinomial in the form where we can use this procedure, the AC method, let's still factor out the GCF. I mean, these numbers are pretty, they're not terrible, but let's factor it out anyway. So we know that there's a non-zero constant term, okay? So we have m equals 0. right? So again, that just means you can't factor out x from here, right? When m is 0, the smallest exponent of x, in other words, is 0. Now for the coefficients, well, for 16, what are the factors? We have 1, 2, 4, 8, and 16. For 34, what are the factors? Well, we have 1, we have 2, we have 17 and 34. To actually get the factors of these, we know, for instance, that 2 is a factor of 34, right? So because the last digit is even. And if you divide by 2, you get 17. And 17 is actually one of those numbers that the only factors of it are 1 in itself. So, I mean, if you ever need help getting the factors, just, email me. I think most people coming into class know how to do that. 18, know how to get the factors, I mean. 18, we have these numbers as well. But hopefully you can see that the greatest common factor among the coefficients is 2. So basically the GCF here is 2. I know I wrote 2 times x to the 0. I mean, it's not really precise to write x to the 0, but it is 2 though. So anyway, we factor it out. When we factor it out, you have to divide to see what's left over. And that's the same as dividing 2 into each term. Okay? And when you do that, what do you get? Well, you have 2 in front, 16x squared over 2. That's 8x squared. Here, we have 34x over 2, which is 17x. 18 over 2 is 9, so we're left with this. But hopefully here you can see the benefits of factoring out the GCF. I mean, I would rather work with 8x squared minus 17x plus 9 instead of this one here. The numbers here are, more complicated. I mean, they're not terrible, but they're still more complicated. So we have to factor this. Okay. So by comparing the two, I mean, I didn't write it down here, but hopefully you can still see that capital A is 8. Capital C is 9. Okay, so we want two numbers whose product is 8 times 9, which is 72. And the sum has to be B, which is negative 17. So two numbers whose product is 72 and whose sum is negative 17. Like this. We want to fill in these blanks, so to say. Okay, that's good. Okay, so what numbers work? Well, let's say we tried 8 and 9. I mean, the product is 72. That's not going to work, though, because the sum is 17. We want our sum to be minus 17. Remember, don't forget the minus sign. What about negative 8 and negative 9? That's going to work. I mean, the product is still 72. SAP and Sun rules, I think that's what they use. The sum of these, minus 8 minus 9, is minus 17. So minus 8 and minus 9, negative 8, negative 9, excuse me, that's what we're going to use. Okay, so what do? Well, we're going to replace our coefficient of x, which, again, that's what B is. We're going to replace that with minus 8 minus 9. We're going to replace minus 17, that is, with minus 8 minus 9. So what do we get? Minus 17 times x. That's going to be minus 8 minus 9 times x, right? And remember, we're distributing x. Okay? Distribute. That's what I'm showing here. You must distribute the x. Okay? We have to distribute that. Once you do that, you get minus 8 times x minus 9 times x, excuse me. Okay, that's great. Let's substitute. In other words, minus 17 times x, we're going to replace with minus 8 times x minus 9 times x. That's what we're going to substitute, like so. Okay, minus 17 times x, we're replacing that with minus 8x minus 9x. And now you can see that we have 4 terms. We have a polynomial with 4 terms in it. What do? Factor by grouping. Now, part of factor by grouping is to factor out the GCF, but it turns out here that the GCF is 1. Mostly because there's a non-zero constant term here. So you can't factor out x, or in other words, m is 0. And I show it over here, but the factors of 8 and 9, well, the only common factor there is 1. So the greatest common factor among the coefficients and the constant term would be just 1. So you would have 1 times x to the 0, which is 1. So the GCF is 1, basically. Okay. Okay. All right. Anyway, now what we want to do, remember, is form those 2 groups, right? And remember, what I like to do is I like between the second and third term to have addition. I like to have addition between the second and third term. So this subtraction, I'm going to change it to adding the negative. I mean, if you don't do that, but you do everything correctly, that's okay. It's mostly the negative sign over here in front of the 9x that you have to worry about. You have to include that in parentheses, which is what I'm doing. So we form these 2 groups, as you can see. Now we have to handle each of these 2 wonderful groups. And it's basically just factoring out GCFs. That's what it boils down to. For the